Hello and welcome to a video where I will briefly talk through the answers to exam style questions from Unit 2.6. Name the gas A. Gas A is hydrogen. Name catalyst B and why is it used? Catalyst B is an ion catalyst. This is used to speed up the reaction and increase the rate of the reaction. Question 1c. What happens to the unreacted gases and why is this important? The unreacted gases are recycled and returned into the reactor. This is important. It reduces the cost of the process and means that less waste is produced from the reaction. Describe how the yield of ammonia varies with temperature and pressure. There is a lower yield with higher temperature and a higher yield with higher pressure. Write a balanced equation for the production of ammonia. So we have N2 plus 3H2 goes to 2NH3. As you can see, the number of nitrogen and hydrogen atoms all add up with the balancing I've put in place here. Using only the data in this table suggests the conditions that should be chosen for the process. So from looking at this data, we can see that the process that should be used is 1000 atmospheres and 100 degrees C. This is because it gives a 99.9% yield of ammonia, which is the best by far in that table. Give the disadvantage of using a low temperature in the process and state how this problem is overcome. So, by using a lower temperature, it would mean we have a lower rate, which would mean a slower reaction. This isn't what we would like in a process in industry, so this is overcome with the use of an ion catalyst, which will speed up the reaction. The actual pressure in the process is 200 atmosphere. Apart from safety issues, suggest a disadvantage of using a higher pressure. So these could be the cost of containers. This is because obviously a container built to withstand higher pressures would be more expensive, and it would also be a higher cost of getting to the higher pressure. Give the term used to describe a reaction that produces heat. So this term is exothermic. Balance this symbol equation. So from looking at this equation, we can see that we need to balance the NO2 and the HNO3. So this is done by adding a 4 in front of the NO2 and a 4 in front of the HNO3. Now all the atoms on each side of the equation add up. Write a balanced symbol equation for the reaction that occurs when nitric acid is added to copper carbonate. As you can see, this equation below is balanced. Name the pungent gas A. This gas is ammonia. We know this because it turns damp red litmus paper blue. Give the chemical name of the blue precipitate formed. This is copper 2 hydroxide. The green precipitate formed is iron 2 hydroxide. Give the chemical formula for this compound. Here we have F, OH, and we have 2 of the OH groups. Universal indicator turns red in sulfuric acid and orange in ethanoic acid. State what these results tell you about the strength of these acids. So from looking at this table, we can see the pH of something that turns red is 0.2, and the pH of something that turns orange is 3 to 4. Therefore, we know that sulfuric acid is stronger than ethanoic acid, as we have lower pH values associated with this acid. Both acids react with magnesium, forming hydrogen gas. Now A, state how these reactions differ. So when reacting with sulfuric acid, we know that sulfuric acid is a stronger acid, so the reaction would be faster. This is because it's more reactive. There'll be more bubbles and the reaction would get hotter because of this. Give the test you would carry out to identify hydrogen. Well, if you have hydrogen, a lighted splint held in the gas would pop. Name the raw material that provides oxygen in stage 1. This would be air. Describe the last 2 stages in the contact process. So stage 3 would be that we would dissolve sulfur trioxide in concentrated sulfuric acid, And stage 4 would be that we would dilute this with water to then produce concentrated sulfuric acid. Name the catalyst that we would use in stage 2. This is vanadium pentoxide. When concentrated sulfuric acid is added to sugar, a black solid is formed. In terms of the elements present in sugar, describe what happens during this reaction. So the acid would dehydrate the sugar. This would remove the elements of water, hydrogen, and oxygen, and leaving only carbon behind, which would be seen as the black solid. One of the main stages in the manufacture of sulfuric acid is the reaction between sulfur dioxide and oxygen to form sulfur trioxide. The balance equation can be seen here. We have 2SO2 plus O2 going to 2SO3. Use this graph to find the increase in percentage yield if the temperature is reduced from 650 degrees C to 450 degrees C. So if we read across the graph at 650 degrees C, we have a 55% yield, and at 450 degrees C, we have an 85% yield. We know the difference between 85 and 55 is 30, so we have a 30% percentage increase. 1 molecule of sulfur trioxide reacts with 1 molecule of sulfuric acid to form 1 molecule of oleum as the only product. Here is the balance symbol equation for this. The only balancing that did need to occur was that there are 2 moles of sulfuric acid. State what you would observe when a few drops of concentrated sulfuric acid are added to a beaker containing a small amount of sugar. Name the product. So a black mass or solid would form. From the sugar that turns black, there would be some steam, some water vapour, it would smell. And the product we would have obtained is carbon. Describe which test is which and identify the unknown compounds. So, test 1 would be a flame test. Test 2 would be the addition of silver nitrate solution. Test 3 would be the addition of NaOH and warm. And then a test gas given off with damp litmus paper. For test 4, we would add dilute hydrochloric acid and bubble gas given off into lime water. And for test 5, we would add sodium hydroxide solution. Now to identify the compounds, compound A would be sodium iodide, compound B, ammonium carbonate, compound C, calcium chloride, and compound D, iron 2 carbonate. Describe this test for sulfate ions in solution. Include the results. Now we would use barium chloride, and this would give us a white precipitate if sulfate ions were present in solution. Describe the benefits of the use of nitrogenous fertilisers and the problems that arise when they are washed into rivers. Now this would be a long answer question within the exam, but to summarise the points, we have the benefits and problems shown here in this table. So the benefits is that the crop yield is increased, meaning we have more food, the plants are healthier, the quality of the soil is improved, and there are cheaper food and the land can be used for other purposes. Problems include the increased soil acidity, the fact that water supplies can become polluted, meaning that nitrates are present in drinking water, and it can lead to the overgrowth of plants in canals. Thank you.